Suppose some linear non-linear equation is given, how to convert it into linear equation if it is of the certain form. So this method is known as reducible to the linear equation, and this was also known as Bernoulli's equation. So Bernoulli's equation is essentially y dash plus pxy is equals to qx y power a, where a is some non-zero number. So if a is 0, then this equation will become nothing but linear differential equation, right? So therefore the only difference is here we are getting extra term, that is y power a, where a is non-zero. So we can substitute here to solve this type of, suppose this type of differential equation is given. To solve this differential equation, what we will do is we will convert this part as a y part kind of thing. So for that, what we need to do is we need to substitute some function u is equals to y power 1 minus a, and it will, this substitution will convert the Bernoulli's equation, the given Bernoulli's equation, into the linear equation. So let us see one example of this Bernoulli type. So we want to solve here a differential equation, which is first order differential equation, dy by dx minus y by x is equals to y power 3. So if you compare this differential equation with the standard form, then this is nothing but dy by dx plus some function px times y, where px is minus 1 upon x in this example, and is equals to by power a, where a is non-zero. So in fact a is different from 1 also, otherwise we can take the y term on the other side and it will be again a linear differential equation. So this is the differential equation. To solve it, we can see that here, so this is a solution. Here y power a is y power 3, that means a is equals to 3, right? So in this differential equation, what we will substitute is, we will substitute y u is equals to y power 1 minus a. So that means so we shall consider the substitution. U, which is a new function of x, which is nothing but y power 1 minus a. So that is y power 1 minus 3 is y power minus 2. So this substitution we will consider, and therefore what will be du by dx, the derivative. So u is a function of x because y is a function of x. So the derivative of the function 1 by y square is nothing but the derivative of y power minus 2 is minus 2y power minus 3 times dy by dx. Right. So we will substitute u is equals to y power minus 2 and du by dx is this term. So what essentially we will do is we are actually making power of this function to be y, single power. So let us see that multiplying the given equation by y power minus 3. So y power minus 3 means essentially we are dividing by y power 3, right? So multiplying this we get a new equation. So that will be y power minus 3 times dy by dx minus y power minus 2 times 1 by x is equals to 1. Okay. So therefore we get y power minus 3 dy by dx minus 1 upon xy square is equals to 1. So now we will see why we are substituting this particular function. So if we substitute y power minus 2 to be u and y power minus 3 dy by dx is equals to minus half times du by dx, this equation will convert into the linear equation. So the first term by this substitution we'll get minus half times du by dx. The second term will become minus 1 upon x times u is equals to 1. So essentially this equation is du by dx plus 2 by x, which is a function of x, times u is equals to minus 2. So we just multiplied by minus 2. So this new equation is a linear equation in u and x. Right? It is a first order linear differential and we know that how to solve a linear differential equation. We have an integrating factor for the first order linear differential equation. So this is the first order linear differential equation with integrating factor which is e power integration px, that is 2 by x dx. So this integrating factor will become integration of log x square, right? And this is nothing but the function x square. So in this example, the integrating factor is x square. So we will multiply by x square, it will become exact differential equation. So therefore we get exact differential equation which is x square times du by dx plus x square times 2x, that is 2 times xu is equals to minus 2x square, right? So this is our new differential equation which is exact because the left side is the derivative of x square times u, right? So this is d by dx of x square times u, where u is a function of x, is equals to minus 2x square. And then we know that to solve this differential equation we need to integrate this equation. So it will become x square times u is equals to minus 2 integral of x square dx plus constant of integration. So finally we get x square u is equals to minus 2x cubed by 3 plus constant. So therefore what we get is we get x square u plus 2x cubed by 3 is equals to c, where what is our u function? Our ux function is y power minus 2, right? And we want the solution finally in terms of x and y, not in terms of x and u, because u is the substitution. So we will substitute u again, and we get the final solution is x square by y square plus, yeah, so this is a mistake, should be equal here. So this will be the general solution of the given Bernoulli equation. So what we have done basically is that we started with we were given Bernoulli equation, and in which power of there was a term of y power 3, so that y power 3 term we need to convert into y term uh, by substitution basically. So for that we have taken the substitution y power minus 2, and then we converted the given differential equation into the differential equation in terms of u, and which turns out to be the first order linear equation, and then we know how to solve the first order linear differential equation by integrating factor method, and finally by substituting the u function again we get the final solution in terms of x and y. So whenever the Bernoulli differential equation is given, we will solve the method in this way. Okay, so this is regarding that method. Now in school mathematics we studied the angle between two lines. Suppose we are given two lines of the form mx plus c. So first line is y is equals to m1x plus c1. The other line is y is equals to m2x plus c2, and these two lines makes alpha angle, right? So angle between them is alpha. So then what will be the relation between alpha and m1 and m2? So the acute angle alpha between the lines whose slopes are m1 and m2 is given by, so basically the relation between angle and the slopes is given by tan alpha is equals to modulus of m1 minus m2 divided by 1 plus m1 m2, right? So this we already know, and in this case basically plus or minus tan alpha is m1 minus m2 by 1 plus m1 m2, and we know that if the lines are perpendicular, then the denominator term will gives us the condition that m1 into m2 is equals to -1. Right. So this formula is for the lines. So the question is, can we extend this formula this notion of angle for the curves other than lines. So here only lines were given and angle between line was discussed. So this idea gives a notion in terms of differential equation that is known as orthogonal trajectories. So let us see what is first of all, what do we mean by orthogonal trajectories? So we say that two families of curves form orthogonal trajectories to the yes, we say that the the families of curves, the given family of curves form orthogonal trajectories to the other given families of curves if each curve in the first family is orthogonal. So where it is orthogonal? At the point of intersected, at the point of intersection. So we have two families of curves which intersect with each other at certain points. So at the point of intersection, the first curve in the first family is orthogonal to the other curve in the family. Let us try to understand this by a diagram. So suppose we are given family of curves. So this is the green family of curves, the first family of curves, which we have drawn with green color. The other family of curves is given with the blue color. So the first family and second family, one curves, they intersect in this particular point. So what do you mean by if these two families are orthogonal? The family is orthogonal if they intersect at the point orthogonally. That means the tangents which intersect at this point are essentially perpendicular. So the slope of the first curve is, let us say it is dy by dx. Then using the formula m1 into m2 is equals to -1, we get the other slope to be minus 1 by dy by dx, right? So this is the idea which we are going to use here to find the orthogonal trajectories. So let's write down that to find orthogonal trajectories, we find the differential equation of the first family. So this differential equation, let us say it is dy by dx is equals to some function of x1. Right? So the differential equation we can write in this form: first order differential equation, and then we solve, we replace dy by dx by minus 1 upon dy by dx, right? So that means basically going from one tangent to the other tangent will go, and then we'll find out the 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 curves corresponding to the new differential equation, right? So we replace by this, that is we solve the differential equation which is minus 1 divided by dy by dx is equals to f of x1. The solution of this new equation gives us the orthogonal trajectories. Okay, so let us discuss one example of this kind. So find the orthogonal trajectories of family of the straight lines passing through the origin, right? So, so let us start with the equation of straight line. So we know that the simple form of the equation which of the line passing through the origin is y is equals to mx, right? So we know that the equation of the given family of lines is y equals to mx, where m is the slope. So what is given is we are given several lines which passing through the origin, and we want to find its orthogonal trajectories. So what we'll do is we'll first find the differential equation of this family. So we know that how to find it. We need to differentiate it. So derivative is dy by dx equals to m, right? And m is the constant, so we need to use this equation to eliminate the constant. So essentially we get m is equals to y by x. So the differential equation is basically xy dash is equals to y is the differential equation of the given family. So now what is the differential equation of the other family, the orthogonal trajectory families? So basically we need to replace instead of y dash minus 1 upon y dash in this equation. Right. So therefore the differential equation of the orthogonal trajectories is minus 1 upon y dash is equals to y by x, right? And in other words, that is x plus y by dash is equals to 0, right? So we got the differential equation of the orthogonal trajectories which are orthogonal to. So this is the differential equation of the curves which are orthogonal to the lines. So now what we'll do is we will solve this differential equation and we will extract the curve which is orthogonal to lines. So let us solve it. So since we have this differential equation, we can also write as x dx plus y dy is equals to 0. That is nothing but exact derivative of x square by 2 plus y square by 2, right? And then we just integrate it, we will get the solution. And we can rewrite this in a more better form by multiplying 2 on the right. So what we'll get is 2c dash, we can say it's c. So this is nothing but the equation of, we know that this is equation of circles centered at origin, right? So in this process what we have verified is we were given the family of lines which passes through origin, and what we got essentially is we got the orthogonal families to lines which are the circles centered at origin. So at the point of intersection, the tangent of this circle and this line are perpendicular, right? So this is regarding the orthogonal trajectories, how to find it. So the main thing we need to care is when we get the differential equation, we need to eliminate the constant, like we eliminated m here. So that is the important part. More generally, as we mentioned, that we can find the angle alpha between lines. So that notion is known as oblique trajectories. So when the angle is other than 90 degrees. Yeah, so if you have any doubt, you can stop by me and unmute and ask also. So any doubts so far? Yes. Okay. There is no doubt. I will continue. So in oblique trajectories, we are given two curves in the same way as orthogonal trajectories, and we have tangents at the point of intersection, and angle between tangents is alpha. So what we will do is we will do the same procedure here. So the first family, suppose the differential equation is f of xy. So instead of that, what we will do here is we will use this equation and substitute it in the equation of tan alpha. So instead of m1, we will substitute fxy, right? Instead of m2, which is nothing but the slope, so we'll keep it as it is, y dash, and then we will get 1 plus fxy into y dash. So this formula is coming from that tan alpha is equals to modulus of m1 minus m2, 1 plus m1 m2. Right?
Sir,
Yes. Yeah. So basically, to find oblique trajectories, so that means we need to find the curve. Given curve is, let's say this one is the given curve. We want to find the other curve which forms alpha angle with the first curve in the first family, right? So that alpha, suppose alpha is other than 90 degree. So how to find a trajectory which is making, let us say, 60 degree with the first family of curves. So to find such a family, we will use this. We will solve this differential equation, right? So given curve, the first curve is this one. The first curve, first family curve satisfies this differential equation. Dy by dx is equals to f of xy. So using this f of xy, we will make a new differential equation which is tan alpha is equals to modulus of fxy minus y dash divided by 1 plus fxy into y dash, and this differential equation we will solve the second differential equation, we will get the second family. So this is the method. Let us see the example. It will be more clear with the example. So in the example, we want to find the family of curves so whenever the angle is 90 degree between curves, it is called orthogonal trajectory, and whenever the angle is other than 90 degree, it is called oblique trajectories. So we want to find the oblique trajectories which intersect the family of which intersects the family of circles so let's say the circles are centered at origin and radius is r at the angle 45 degree. So what is the procedure? Procedure is that we are given the angle alpha is equals to 45 degree, right? And we are given the circle, the equation of circle. So first we will find this differential equation from the equation of circle, and using whatever f we'll get for these circles, we'll substitute it here and we'll solve this new differential equation in terms of tan 45 degree. So let us first find out the differential equation of circle. So we just now solved it, but let us find out this. So whenever we want to find the differential equation, we differentiate the equation of the curve with respect to x. We get 2x plus 2y is equals to 0. Sorry, 2y dash is equals to 0, and that will gives us y dash plus x is 0, and that is nothing but y dash is equals to minus x by y. Right, so this is dy by dx is equals to f of xy. So compare with we get fxy is equals to minus x divided by y. Right, now we got the function f. We just substitute in the second formula. So therefore now tan alpha is 45 degree is equals to modulus of fxy minus dy by dx divided by 1 plus fxy dy by dx. So let us see what this gives. So we know that tan 45 degree is nothing but 1 is equals to modulus of fxy is minus x by y minus y dash divided by 1 plus minus x by y dash. So now we get two cases, right? Because we have a modulus here, so plus or minus 1, we will get two cases. So we get two differential equations. First one is minus x minus y dash is equals to y minus xy dash. This is first case. The second case is minus x minus y dash is equals to minus y plus xy dash. So depending on the right hand side is positive or negative, so plus is equals to plus 1 or minus 1. The first differential equation, if we want to solve, it turns out to be y dash is equals to x plus y divided by x minus y. The right hand side equation will become y dash is equals to y minus x divided by x plus y. So just verify this. I have already noted down in my notes, so I have written it directly. You just verify it if there is any mistake. So then we know that this is a homogeneous differential equation in x and y. So that means we can substitute y is equals to vx to solve it, and in that case y dash will be x v dash plus v. So substituting these two in the given differential equation, we'll get x v dash plus v is equals to 1 plus v divided by 1 minus v, and then taking v on the other side, we will get x v dash is equals to 1 plus v divided by 1 minus v minus v. So that is 1 plus v minus v plus v square divided by 1 minus v. So I have taken LCM with respect to 1 minus v. So let us see on the other side what we are getting. So on the other side, if we substitute the same substitution, so it will give x v dash plus v is equals to v minus 1 divided by 1 plus v. Right? And then it turns out to be x v dash is equals to v minus 1 minus v plus v square minus v square divided by 1 plus v. Alright, so these are the equation we are getting. Simplifying this, we will get 1 plus v square divided by 1 minus v. On the right side, we get minus 1 plus v divided by, sorry, v square divided by 1 plus v. So going further, we can convert this differential equation into separable form. So this is actually in the separable form where v and x we can separate, and then we can integrate this equation. So this is basically 1 plus v square dv minus half 2v by 1 plus v square is equals to dx by x plus constant. On the other side, the equation will turns out to be and to integrate it, we will get log c or log mod c, right? So now we know that the integral of all these terms, this is tan inverse v minus half log 1 plus v square is equals to log mod x plus, yes, so here also we can consider log c. So we'll get the answer in a better form. So this will become minus tan inverse v minus half log 1 plus v square log mod x plus log c. So left side will become so we can multiply by minus 2. So essentially, um, yeah, multiply by 2. So we get 2 tan inverse v is equals to log 1 plus log 1 plus v square we can take on the other side. So it will become plus. So it will be in the multiplication of, and 2 times log x will become x square times c, right? So finally, we can substitute v is y by x. So the solution is tan inverse y by x equals to log 1 plus y by x square into x square times c, and right side it will be minus tan inverse y by x, so that we can multiply by 2, and that is log of 1 plus y by x square times x square into c. So we got these two family of curves We're essentially getting two oblique families. That is what uh, we are getting in this case. Yeah, so in this matter, do you have any doubt?
No,
How
sir.
to find it? Okay. Okay, so I think let me stop the recording. This will be enough for today lecture.